Yep.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to Coffee with Caleffi. Thanks for tuning in and joining us today. We're going to do it a little bit differently today. We're going to kind of do a tag team event. Mike Schreiner, our Director of Engineering, is going to do the heavy lifting, and I'm going to go in for the tag. So we're going to talk back and forth a little bit, and I'm going to try and monitor the questions and hopefully answer the questions when we're on the slide, because sometimes we get to the end and we've got questions and we don't know what slide they were referring to and stuff like that. So we'll see if this will run a little bit smoother for everybody and get as many questions answered as we can as we go along. So Mike Schreiner, some of you guys know him. We don't let him.
All right. Yeah, like Hot Rod said, we spent some time talking to a lot of installers and designers and stuff, and the one thing, we saw up there was there certainly is a need for some simplified wiring. Here's just kind of a joke case here. It looks like somebody had taken some other relay boxes and pulled the circuit boards right out of them and then wired, you got exposed 120-volt wiring and things like that on here. So what we wanted to do was to try to simplify the wiring as much as possible, try to eliminate wire nuts and the complexity, but at the same time still make it flexible so it can handle, all the different types of jobs that you have. The family of products, we basically have 3 different families inside of here. They are all approved by ETL for CUS, and it conforms to the UL 873 standard. So the first one is the simplest one. We call it the ZSR 101. It's a single zone switching relay. It's basically a double pole, double throw relay. Has a 5 amp capacity on each leg, and it's compatible with all 2, 3, and 4 wire thermostats. We'll get into the details of our wiring later. It has 6 electrical knockouts, 3 on the top, 3 on the bottom, and one thing that's kind of neat is that it can mount to a 4x4 electrical box, so you can really get a nice clean looking installation on these. The next member of the family is basically the MultiZone pump control. So it's our ZSR 103 through 106. We offer it in a 3, 4, and 6 zone model. The base unit, they're expandable, and they're expandable without limitation as well. So you can daisy chain as many of these units together as you would like. What we output is 120 volts AC to the pumps. We're not just providing a switch, but we're providing the voltage output. There's a 5 amp capacity for each pump with a 20 amp total. Up and beyond the pump, the zone control pumps, we also offer a primary pump output and a domestic hot water switch, or ZRZC switch, because it's rated up to 120 volts and 2 amps. So on some of those systems out east, like the Levesque brothers showed me, this is a perfect match for those types of controls. It has selectable priority, and there's a 1-hour timeout on that, so it can prevent freeze-up. Pump exercise is selectable, and that works by if there is no action by that pump for 72 hours, it'll run it for 3 seconds. And it's also, each one of the pumps are independently timed on that. So it's not just all of them get it or all of them don't. Each pump is individual. There's a post-purge option, and then also something we call the status of the primary pump during priority. So what that allows us to do is you can decide whether you want a primary pump to run during the priority mode. We'll show some of the schematics with that later too. 5 amp slow blow fuses, 2 extra fuses under the cover. This one has 12 electrical knockouts and the front LEDs for easy diagnostics. Then the last member of the family here is the valve control. That comes in a 3, 4, and 6 control. Again, it's expandable. They communicate with each other. There's no real limit on how many you put together. It will control your zone valves, and also it can control a system pump, what we call a system pump, which could be your primary pump, a secondary pump, and a priority pump. So it gives you a lot of flexibility. Also, the pump exercise on this is built in. It's not selectable. It's going to happen 72 hours, no activity. It'll run for 30 seconds. Selectable priority, again, with the 1-hour timeout, and I'll explain the timeout a little bit later. We have automatic resettable fuses, and that's actually true on all of the controls. On the 24-volt side, if you would short out a thermostat, it's going to short out that resettable fuse. Once it cools down, it closes back up, and you're up and running again. So,
and we've certainly tested that feature. We know that
yeah.
works.
Yeah, we definitely tested that in the lab a few times unintentionally. Again, it has the domestic hot water switch, or the ZR-ZC switch, rated at 120 volts. And we also provide 120-volt outputs for the pumps in this control as well. It's not just switches. Again, it's to try to make the wiring as simple as possible. 12 electrical knockouts in the front LEDs. If you probably noticed, both the ZSR and the ZBR, they're in the same plastic enclosure. The labels are a little bit different, though. So let's keep rolling here. We'll focus in on the single zone. We use a snap fit cover on these. It does require a tool to open up the cover. You're going to need a screwdriver. The best way to open it is grab the cover and just give that snap arm a tab, and then spin it around, do the opposite side, and the cover will lift straight off. But you're on the small unit, you do have to release both snap arms before that cover is going to come off for you.
And then I think, Mike, you talked about has to do with the listing on it. You can't make it that, it has to be a tool to remove it, or the listing is different and changes. So it's not trying to make it hard,
correct.
But that's part of the requirement.
The UL standard requires that it requires that a tool be used to remove the cover.
Yep.
So once you have it open, this is what the board looks like. We went with a black board with white text on it because it really jumps out at you in a dark boiler room. You can really see this well. We have a 60A transformer on board, and then we have our dual labeled T-stat terminals. Like we said, compatible with 2, 3, and 4-wire thermostats. So we dual labeled it. Just some guys are used to seeing the RWC, other guys are used to seeing TT. We also identified the common there. We have 2 replaceable fuses, one for each relay. We have keyhole mounting to fit on the 4x4 box as well. This is a rear knockout. If you are going to mount it on a 4x4 electrical box, this is your access to get back into that box. And then we also put in a pre-installed jumper between line and common on that first relay. It's the most common way of doing it. That way you can run power to your system pump right off of that.
And a question came in, Mike, and this is a good spot to answer it, what a double pole, double throw, or a double throw relay is. And that'll be in Hydronics 14 if you get that too. We explain switches from the very basic thing, but right there is a good example of where you've got a normally open and normally closed.
Right. We have 2 sets, 2 sets of contacts, and then normally open and normally closed on each one of them. Yep. So that's what the double pole, double throw really means.
Yep. Okay.
So getting into the stat wiring, the 2-wire stats, it doesn't matter if it's battery operated, a mercury bulb, a bimetallic, or a power stealing stat. They're all going to connect up to the R and the W contacts. The R is really your 24-volt supply. C is common, so if you put a voltmeter between R and C, you're going to see 24 volts AC all the time. What fires the unit is when R gets connected to W. So your 2-wire stat, if it's just basically like a dry contact, it's going to bring R and pull it back to W, and that's what initiates the heat demand. The 3-wire stat, which has really become a lot more popular, especially as you get into the displays and the internet access and touch screen, it requires more power. And the power stealing stat, it can't really grab that much power to run it all the time. So on those, it's real simple. Most of them are wired R, W, and C, straight up to R, W, and C. You will see some variations sometimes in these here. It might be W, like on a ecobee, I think it says W/OB. Sometimes you'll see RH for heating, W1, a couple of different variations, but for the most part, it's going to be RWC.
Yeah, and we've tried it with quite a few different thermostats, just trying to see what's out there. We probably bought a dozen different brands and types of thermostats to check the compatibility, and yeah, there are different wiring things. But typically, the installation manual for the thermostat will explain, where they want the power and the common and stuff.
Yeah. When in doubt, check the manufacturer's instructions.
Right.
And what we call a 4-wire stat, this happens to be a pull from a Techmar stat. But these stats here basically have a separate 24-volt supply, and then they have a separate switch, and that's what you see over here. But you can power these stats directly from our control. Again, R to R, and W to W, they call it W1, and C to C. That way the stat will get its power, but you have to put a jumper inside the stat between R and RH. And that is clearly marked in the thermostat's instructions as well. But just to show you that it really doesn't matter, we can cover all of these different types of stats with our control. And these are common. The footprint that we have here, the labeling, that's common among all our controls. And then the last thing is just a dry contact, which is obviously, it's similar to a 2-wire stat, or it could be like a mercury bulb type of stat. But even if you had whatever your configuration is, if you were pulling off of an end switch from a zone valve or some other control, you just need a dry contact here, and that'll pop it and initiate that heat demand.
And another common one there is guys that are doing snow melt, they want to put like a 12-hour spring-wound timer on to run the snow melt instead of some kind of automatic control. That's where you'd hook it up. So it just makes that connection there and enables your heat demand by just closing that contact through a spring-wound timer switch or any kind of timer switch. So.
Yep. All right. If you want to mount this guy to the 4x4 electrical box, as I mentioned, there's a rectangular knockout. Just get a screwdriver in there, give it a little twist, a couple areas, and break all those tabs from the main part of it.
Yeah, there are knockouts in the bottom. You can see on that one there's 3 of them. But I really like this function here because a couple ways you could do this. I mean, what's nice about this, if you want to land a conduit or some flex or some liquid tight or something into a metal box instead of the bottom of the relay box itself, you can land all this stuff and then come back later after the sheetrocking and the painting and everything's done and then put your control on it that way. Or the other thing you could do, if it's a new construction, you can buy those metal 4x4 boxes with a nailing plate built right into them. It's welded right onto the side or crimped on the side of it. So you could have that box in the sheetrock wall. They sheetrock, they paint, you come back, and now your relay box would flush mount to the wall and it would look really pretty. You wouldn't see that conduit or that box or anything because it would be hidden by the sheetrock and stuff. And even if they router around it a little bit big, because I know some sheetrockers use a router to go around those boxes, you can see the relay box covers the metal box by about a ½ inch or more on all dimensions. So if they get a little wild cutting it out, you still got a big enough, back on the relay box to cover it, make it look really nice. So that was a nice.
Yeah, once you mount it on here, you got the keyhole feature, so you drop it down on there, fasten those down, pull the wire through, do your wiring, and put the cover back on. It really gives you a nice finished look.
That's a good slide, Mike, to show how you can see the indicator lights on it. Notice how we dish back the cover there, so the lights are right there. You don't have to look down a light tube or something to see if the lights are activated. So it's a really clear shot of them. Great.
So, a typical application, got a couple application drawings here, just showing a single zone, 3-wire stat wired up to here, ground, neutral, and line coming into the control. We got our jumper going over to common. So if there's a call for heat, the relays fire, and that's going to take your line voltage, bring it over to the normally open contact. That's over to your system pump. That'll fire up your pump. And at the same time, the common and normally open are wired up to the TT of the boiler, and that'll give the boiler the heat demand. So, call for heat, pump turns on, boiler fires. Pretty simple stuff.
Yeah, probably one of the most common ones too.
Yeah. Here's another diagram. It's not as common. It's not my most favorite, but you do see it done quite a bit. What they have here is a separate 24-volt supply, and one leg goes to the thermostat, and then out of the thermostat it goes to the motor lead of the zone valve, and then the other leg of the 24 volt goes to the other lead of the motor valve, up to the zone valve. So when there's a call for heat, the thermostat calls, it'll supply 24 volts to this particular zone valve. When that zone valve is open, all of the end switches are tied in parallel back to the TT contacts on the control. So that'll close these contacts here, and that will initiate demand. So it's wired down here just the same as the last schematic was. In this case, we show a variable speed pump. But if any of the zone valves close, the relay control fires, the pump turns on, and the TT gets closed so the boiler can do its thing.
And I'm not sure what the intention of this one is. I guess just instead of buying a 3-relay board to save some money.
Yeah, it's a four-man's relay.
Yeah, I mean, I don't mean to use that term, in a bad way, but that's what it is. Is somebody that didn't want to spend the money, the 3-zone valve controller, said, well, I'll just buy a single one to do my switching and then use another source for my, sometimes the boiler has enough transformer in it to power those if it's an older test type of boiler.
Yep. And then also here, we just showed, in case you guys aren't aware, that our Z1 valve now is coming with press fits. We call it the press con. We have a few other products as well, pressure differential bypass valves. I think there's a dirt mag and a 3/4 inch fill valve. But it's a pretty neat product. We're pretty excited about this as well. It has the leak detection, so if you forget to press it, you pressurize it, you'll get a good stream of water coming out of it, so you know that you need to go back and press that one.
Yeah, we're excited about that. As you can see, it's got union nuts, so you can take the valve and stuff out. Next month, I think we're doing a seminar on zone valves. We'll be talking more about the different families that those tail pieces can be used on, too. But a little teaser there for you.
And here's another application drawing it's in our Hydronics 14. On the left here, we've got a Modcon boiler with a buffer tank, a variable speed pump, and then we're doing a bunch of panel radiators out here with thermostatic radiator valves out on each one of them. So the idea is to have a master thermostat, and that one's going to be set to a little higher set point. So as soon as the temperature in the house drops below that master thermostat, it's going to initiate a demand to the relay box. So the relay box then will fire up the TT contacts on the boiler, and the boiler then is going to look at the outside air temperature, and it's going to adjust the temperature inside the buffer tank to meet that temperature, that desired temperature based off of the outside air reset curve. And at the same time, we'll be firing up the variable speed pump so that the fluid is available as the TRVs start to modulate flow. The valves, there's fluid for that to flow through the panel radiators. So it's kind of a neat system that gets you one thermostat and gets you your individual room control, and it's without electricity really out on these TRVs. So with that, we're kind of done with the single zone, and we'll move into the multi-zone, which is in a bigger enclosure. You can see we go up to 6 zones. They have the LEDs on the front cover here. And to remove this cover, you only need to remove one of these tabs. There are 2 tabs. There's one on each side. But when it's freestanding, you can grab the cover and basically just take a screwdriver, push it in, and kind of push it down, and it will pivot or roll off from one side. You don't need to try to snap both sides and stuff like that. Just do one side and let it pivot off.
And either side will work too, of course.
Yeah, either side. We have 12 electrical knockouts, 6 on the top, 6 on the bottom. And once you open it up, you're going to see we got a lot of room. We got a large wiring compartment in here to make it easy to get those wires in. So you got big fingers, and trying to get in there will give you a lot of room. The 3 and the 4 zones, they come with a 12 VA transformer. This transformer is really only powering the thermostats and a little bit on the control board. The 6 zone comes with a 20 VA onboard transformer.
And that's mainly for power steering thermostats or something like that, so there's enough available current.
Yeah, either power steering or a 3-wire.
Yeah.
So once you pop it open, this is what the board looks like inside. Let's kind of go around the horn here. This is our XX, and that closes on a heat demand. And it also does close when there's a domestic hot water call. Now these are smaller terminals, but they are rated for 120 volts, 2 amps. They have the proper spacing, and the board traces are spaced apart enough that we do have 120 volt capacity up here. As well as this is our domestic hot water contacts. So if you have some of the newer boilers, Modcon boilers, they're just using 24 volts there, but some of the older oil-fired units with a reset curve, you know, they'll have a ZR, ZC, which is 120. So you are able to switch that, and you are able to fit a 14-gauge wire into there as well.
Yeah, there was
Again,
about those mixed voltages there, but I mean that did pass the you know, the approval, so it's not something we came up with.
That's right. Yeah, it's approved by, like I said, approved by ETL. Yeah. Again, the thermostat connection area is common among all of our controls, so they're dual labeled. We talked about that. Now here's where the communications occurs. It's a 3-wire communications to all of the boards. There's a D, a P, and a ground. It will communicate from the boards whether there's a demand or whether there's a priority call on the other boards, and control the pumps and valves accordingly. There's a power LED.
On the communication, Mike, a second, let me interrupt. What's the wire that's needed to connect them to communicate?
Just a bell wire. It's a 5-volt control signal going between those.
Yeah, so it doesn't have to be a line voltage wire for the 120 volt. It's just communicating through a thermostat wires, shielded wires.
Yeah, that's all low voltage.
Yep.
So over here, the power LED and then the LED for each zone. So when there's a call, these LEDs will light up. We have a primary pump output down here, and like I mentioned before, we are giving you line and neutral, not just a switch. And then there's a priority pump. Zone 1 is always our priority zone if it's enabled. Line and neutral to all of these. Kind of skipped over the dip switches here. This is where we do our programming. I'll go into that a little bit later here. But you can see that there's a master, slave, priority on or off, primary pump on or off. That's during the priority mode. There's the exercise that you can turn on or off, and then the post-purge function. So one thing that we heard a lot of is that, you know, the people want ground screws. If we're going to supply line and neutral, we needed to supply ground screws. So we have a lot of grounds right here, so you can bring your line and neutral in, tie your ground in over here. You know, you got enough to cover all of these. You really shouldn't need any wire nuts inside of this.
Yeah, and they're big terminals. You can get a good, like you say, if you're wiring with Romex and you're using solid wire, you've got good, strong, and big enough terminals there to get, you know, wires under it. But yeah, that's the key there, is just get the wire nuts out of the box. Give people enough places to land the wires without having to get in there and twist wire nuts around.
And then this is where all of the replaceable fuses are. 5 amp slow blow fuses, and we got a couple of spares under the hood too if you do pop them.
And then you can see too where the transformer fuse is up there, or breaker, or whatever you call it. I guess it's resettable fuse.
Yeah, these are the resettable fuses. We actually do that on both the 120 volt side and the 24 volt side. So that way, if you get a short, you're protected in a lot of different ways, so that you don't cook the whole board if you do short out a thermostat or something.
Yep.
So this is how the programming takes place. You know, I mentioned that we have dip switches. The master-slave switch, of course, that's used if you have 2 or more controls together. You can only have 1 master, you know, per group of boards. The priority on or off, it's used to set zone number 1 as the priority zone. So it's, you know, that's typically done for a domestic hot water heater indirect. If that zone calls, all the other zones are going to hold off during that priority call. There is a 1-hour timeout feature. So how that works is, if priority calls and it's there for 1 hour, longer than 1 hour, what happens is after 1 hour the control will go out and look if there's a demand by any of the other space heating zones. if there is a demand, it will go out and satisfy all of those space heating demands. Once those are satisfied, it will then go back to the domestic hot water, and the 1 hour timer kind of resets itself. So that way we'll prevent the freeze up. Let's say you got an aqua stack that's stuck. It's not going to freeze up your house because of that stuck aqua stack. The primary on, primary off. What that is during priority call, you have the option to either run the primary pump or not run the primary pump. The reason you would want that is for whatever reason. Let's say you had a hydro separator in your system and you put your indirect on the secondary side of the hydro separator. That priority pump would be running, but you're going to need the primary pump to run as well to get the water over to the boiler. So you could set it up that way if you want. It just gives you a little bit more flexibility. Exercise on, exercise off. We talked about that a little bit. No demand for 72 hours. It'll fire for 30 seconds. Post-purge, that is only for the priority zone. And what it will do is after priority has been satisfied, it'll open up the contacts, the domestic hot water contacts, so it'll stop firing the boiler, but it will continue to run the priority pump for 2 minutes to help purge out some of that hot water out of the boiler.
I had a question here, Mike, while you got a break there. From Bob, he said, can you interchange relay 1 and relay 2 with one being 120 volt and the other a dry contact?
No, all of the outputs are going to be 120 outputs.
They're powered. Yeah.
Right. The only dry contacts would be XX and the domestic hot water contact up above.
All right. I think I got the rest of them.
Okay, here's a sample schematic. Again, this is out of Hydronic. You can see the figures up here. What we've got is a conventional boiler with a bunch of zone pumps and a domestic hot water pump, priority pump. So our wiring on this is we're tying XX to TT on the boiler control. And this has a reset control, so we'd have ZR and ZC over to our domestic hot water contacts over here. An example of that is like the hydrostat. They're 3250 plus. They even show ZR, ZC going to an end switch, so that can do it for you. Got our aquastat on zone number 1, and on this particular case, we'd have priority enabled, and when priority calls, C1 would fire. Otherwise, when any of the other space heating units call, one of these other pumps would call. And when priority calls, of course, these are all held off. So a pretty basic system here. So another one, ModCom with primary, secondary. And this one is just space heating. So we would just be running our contacts to XX here. Nothing too fancy, other than the fact that we do have a primary pump wired up on this one. So the logic is when the thermostat calls, let's say zone number 2 called, when the stat calls, it will turn on zone 2 LED. It'll send 120 volts to that pump. It'll close the XX contacts, and it will also fire the primary pump. And once the stat is satisfied, it'll shut down all of them. So that gets us into the zone bell box. The zone bell box is it's a little bit more complex because you're kind of interfacing the zone bells and the pumps. So what we've done here is we have 1 or 2, depending on what model you have, heavy 40 VA transformers in there. And the first thing we noticed when we got it produced was that the one side is awfully heavy to maneuver and to mount and for shipping reasons. So what we decided to do is we created a new box that the transformers nest separately inside of the box, inside the cardboard box, the shipping box. So once you get it, you remove the cover, just like we showed with the other control, and then you take the transformers out of there, and there's a, I don't show it real well, but there's a little bit of a slot right here. And you tuck the transformer underneath that slot, and then it snap arms up here, and it snaps right in place. Once the transformer's in place, there's a simple plug. It can only be installed one way. Snap that plug in there, and you're good to go. The 3 and the 4 zone come with a single transformer, but they are expandable. So if you had, let's say, a 3-zone unit and you had somebody else's big, power hog zone valve in there, you could add another transformer, plug it in. They're both in parallel, so now you'd have 80 VA to supply out to those 3 zones.
And it's also, obviously, if you had to replace a transformer, it makes it easy. You don't have to drill out any pop rivets or anything like that. You just take a screwdriver and just slide those little tabs over. You can rotate it out of there and replace it, and it's really serviceable. But yeah, it was really awkward to mount it on the wall with that much weight. It feels like it's like 10 pounds of weight on one side of it. And you got like you're trying to hold one side with 2 fingers and get your mounting and stuff on. So the transformers out of the box make it weigh like featherweight for putting it on the wall and mounting it, and then just snap them in when you're ready.
Yeah, it was really lopsided. Yeah, and like Bob said, you can spread these snap arms right here to remove it. It's not the easiest thing, but you certainly can do it. You kind of have to move one tab, pull the transformer over a little bit, and then move the second tab. Unless you got some type of like a true arc, one of those spreader wrenches that you could pull open and spread them both at the same time. But it certainly can be done. It's better than drilling out rivets, that's for sure.
Yeah, it's not hard to do. And you know what else would work is the snap ring pliers, the kind where you squeeze them and the 2 fingers spread out sideways. That would just open it too. So, I mean, you shouldn't have to be doing this, but with all the protection we have on that, the fuses and everything, the transformer should be protected. One question, though, Mike, while I got you here, Bob still got a question on the relays. He said, on your earlier slide, you showed zone 2. Let's see, go back a little bit here. He said, the earlier slide showed zone 2, TT in the boiler. Am I missing something? I'm not. I think this was in regards to his first question about relay 1 and relay 2. Relay 2 being the 120 and the other one a dry contact. I'm not sure what he's calling relay 2 and 1 here.
Oh, I'm sorry. You know what it is, Bob? There's probably a little bit of confusion. Can I back way up here for a second?
Yeah, while we're here.
If we go back to the single zone.
Oh, okay. I know what he's saying.
The single zone, I should have clarified this. The single zone is not outputting 120, okay? The single zone relay, these are, dry. You can think of them as dry contacts, okay? What we are doing is we are giving it this jumper that's factory installed, that does give it the hot leg of 120 over here, so that you can switch 120 here, and this is a dry contact. If you remove that jumper, you basically have 2 sets of dry contacts. So that's a good point. It's a little bit different than the other, the multi-zones are, dedicated, I'll show you on the other one, 24 volt or 120 volt, but this one is more of a dry contact.
Yeah, I see the confusion there. The other ones we purposely powered them, but this one you've got the option for using this as a dry contact or a powered contact by putting a jumper in.
Yeah.
Got it.
That's a really good question, good point.
Yeah, thanks. Thanks, Bob.
Let me pop through here.
Another question while you're popping through, somebody said, have you considered a post-purge on the primary pump? Also, some boilers may require this. Purge out their little heat exchangers, I guess, after the burner goes off. I'm not in there, but it's something we could...
It's not in there, but you know what, guys? Give us your feedback. Because, especially software changes, it's not a huge deal to really make an upgrade to a software change. And get it out there. But even on the hardware, you know, we're all ears. You know, we want to keep progressing the product and making it better. And in fact, you know, when we look at this one here, for instance, what we're going to do is we're going to color code these terminals. So we're, you know, right now they're all black, and you know, we do have lines that segregate them, but we're going to go with like dark black and then a light gray, dark black, light gray, and then we'll do the same thing on the zone valve to match that. That way, you know, it'll just help on the wiring so you can tell, you know, what zone if you're getting it in that right terminal, because you know they are close together, and it can be a little bit, you know, you got to be accurate when you put them in there, obviously. So the different colors will help.
Yeah, and for aging
like
eyes,
you know,
that's exactly right. For aging eyes, that'll be helpful, and that's exactly how we tested the fuses in our transformers. So we learned firsthand that there's a place we can make an improvement fairly simply. So yeah, it'll evolve. Whatever you guys want, we'll try and get in there. And of course, we want to make it, you know, affordable too. We don't want to load it up with so many features that we miss the mark on, but we want to make it do as much as we can and get them out there.
Yep.
Thanks.
Yep. So we're all ears. I mean, any suggestion, guys, you know, make them, and we'll see if you know if we can get it in there without too big of a cost penalty. So. All right. Well, this is the zone valve box with the cover removed. Then after you've installed the two transformers, and like I mentioned, you know, the 3 and the 4 zone come with a single 40 VA, but they are expandable to 80 real quickly and simply. The 6 zone comes with 2 transformers in the box. Again, the same large wiring compartment that we talked about before.
A question, Mike, and I know this was on one of the chat rooms here recently about a humming transformer. What causes this, or you know, why some transformers hum and not? I mean, you can talk a little bit about saturating the transformer and how I don't want to get it too far off track. I know we got a bunch more slides, but.
Well, I mean, I've been told it can be the quality of the steels and the metals that go into the laminates and things like that.
Right.
You know, it's probably not the best quality transformer. I'm sure it can happen, you know, even on good quality transformers. But you know, the nice thing is here, if you do have a problem, you can replace it. I know on some of the other controls, if you got a bad transformer, it's not so easy to remove it.
Yeah. It's, I mean, you know, buyer beware there. If you buy a transformer for $9, it's probably not going to be the same as a quality transformer. So
right.
I'll let you go around the hoop here.
Yeah, I'll go around the horn on this one. The whole upper side looks identical to the pump box that we just talked about. So
now we're on
the
zone control box is what we're looking at now.
Yep. This is the valve box, the zone control box. So the XX, again, it closes with a heat demand or domestic hot water demand rated at 120 volts, 2 amps. Domestic hot water contacts, same deal, 120 volts, 2 amps. You can switch 24 volts here as well. Same labeling on our thermostat connections. We program here a little bit differently, though. We don't have the little dip switch. We're using jumpers. So you'll see here we have a master-slave jumper, and there's 3 pins. And on one side, one side you'll see, like down here, I guess is a little bit better of a photo on the priority switch here. You'll see an on and an off. So if the center pin is jumpered over to the on, obviously priority is on. You pull that jumper out and put it between the center pin and off, then it's off. Or pull it off. If you simply pull the jumper off, it means it's off. You don't necessarily have to have a jumper in for it to work. So again, up here, 3-wire communications, the same. One thing to note, that the valve box will communicate with a pump box. So you can kind of mix and match these controls. We'll show a schematic on that later. I don't think it's a very common thing, but if you get into a funny situation where you would need to have that done, you can do it. We again have a power LED, and then we have LEDs that illuminate with the call for heat. That's this row here. So when the thermostat calls, you'll see 1 through 6, whatever one it is, light up. And then there's an LED that shows when the end switch on the zone valve has closed. Here's our output for our zone valves. So we label it as motor and end switch, which is it matches what we have on our Z151 actuator, the terminal block actuator. But if you're using a Z111, our black leads go to the motor and our red leads go to the end switch. And like I mentioned, zone 1 is always our priority. So whether it's a 3-zone, a 4-zone, 6-zone, zone 1 is always priority. That way it's always consistent. Some other manufacturers, zone 3 might be priority, and then if you get a 6-zone, zone 6 might be their priority. And then we have 120-volt outputs going to the pumps. So we have a priority pump, a secondary pump, and what we call a system pump. The reason we call it a system pump is that it could be a primary pump on a primary-secondary system with let's say, a Modcon boiler and a hydro separator. But at the same time, it could also be just if it's a cast iron boiler, there might only be one pump in the system, so then you would connect that to this system pump.
And now this doesn't need jumpers. Those are powered. You don't have to
Those are powered.
Wire. Those are powered right out of the box, so don't...
Right, line and neutral to each one of them. And then we have the jumper for programming the status during priority. So basically what that means is if zone 1 calls for heat, or as let's say an aquastat, your priority pump would fire. Keep in mind you're going to need a jumper. That's the one time we need a jumper here. We need a jumper in the end switch if you're using a pump, because when the thermostat or the aquastat calls, this contact has to be made before it knows it should fire, because it doesn't know if you're using a valve output here or you're using a pump here. So a jumper in there will cause the unit to fire as soon as the aquastat calls. But it'll fire your priority pump, and then depending upon where you have this jumper, the system pump, if it's on, if this jumper's on, the system pump will fire as well. If it's off, the system pump won't fire. I'll show you some slides on that, why you'd want to do it that way.
Before you leave this one, Mike, a couple questions. Now, it said about the Molex plug on the transformer, so you really need our transformer to replace it. I mean, yes and no. I mean, ideally, you would get it, but if you notice in this picture, you can see there's a black and white there. I mean, a clever person, if you were out on a no-heat call 100 miles from home, you had another transformer, didn't have a Molex plug, it's pretty obvious that you got your 120 volt on your black and white and you're switched on that. We'd rather you just use ours so you don't make a mistake there, but,
yeah.
Voltmeter, a little common sense, and you could put any transformer in and just cut that and crimp it in so you had the one with the Molex plug built into it. So, and then the other question was, sorry about this, I got to scroll through them all here. Yeah, I think that was it on that one. I wanted to. Is this the board that has the optical relays in it, Mike? Is that?
Well, actually, they all do. We use optical isolators.
Yeah, talk about that a little bit, because that's kind of a unique type of relay as opposed to electromagnetic relay, and maybe you can explain how those...
Well, the optical isolators are used, I believe it's on the end switch contacts. Right. Basically what that is you have a switch on one side, and whatever you're switching, the controls that you're switching on the other side, but how it knows that the switch has occurred is through light. So it's 100% separation. When the switch occurs, an LED internal to that chip is illuminated, and there's a photosensor on the opposite side, and the photosensor senses, oh, there's light coming in, then it fires, so that it completely isolates your circuitry from, let's say, your external switch. It prevents, feedback issues and noise issues and a whole slew of issues. It's not the cheapest way to do it, but it is the better way to do it.
Yeah, they're an incredibly long-lasting and real robust relay, which is why you don't have to pull them off there and replace them and have a removable relay. So it's what they're using in a lot of automotive and really heavy-duty, rugged application type of relays. All right, I think that's good on the questions. Thanks.
So I mentioned the status during priority jumper, just a close-up of this. So the status during priority, it refers to the system pump. So, when would you want it off? Well, let's say we had a system like this, and these are just crude schematics to show the concept here, but let's say you had some zone valves, you got a secondary pump, hydro separator, Modcon boiler with an indirect. So there's a priority call, right? In this case, and granted, you could have the boiler potentially control the pumps, but if our control is controlling the pumps, you would want to fire the priority pump, but you would not want the system pump to run. So in this case, the status during priority would be off. So when there's a priority call, this pump fires, the boiler goes to high temp, and you load up your indirect. Once it's done, priority pump shuts down, and then if there's any call for heat by any of these zone valves, the control can fire the secondary pump and the system pump.
And that'll also post-purge on that one, right?
We do not have post-purge on the valve box, and there's a reason for that. I can show you in a second. When would you want that jumper to be set on? This is a schematic conventional boiler. Let's say here's your system pump, a bunch of space heating, 5 zones of space heating, and you're using a zone valve to feed your indirect. Well, in this case, when the indirect calls, and I only have one pump in the system, and that's connected to my system pump. So when priority calls, I have to have that pump running. So in this case, the status during priority is set to on, so that it can move the fluid through the valve and through the boiler. And the boiler knows to go to high heat because the ZR ZC contacts have closed, taking the boiler off of its reset curve. Once it's satisfied, that opens up, and this zone valve number 1 closes, and then any of your space heating valves can then take over again. So hopefully that's clear what we're doing. We're trying to give you the most flexibility as possible without having to, like I said, do jumpers and wire nuts and whatnot.
Question, do you need a transformer for each module when you start busting them together, like between the first module and additional expansion modules?
Yes. Yep. You need power and you need transformers inside of each one of them. So whatever you buy, let's say you go to the distributor and you buy a three-zone valve box and another 3-zone valve box, everything's in there to do it already because the transformers are in there. You just have to bring line, neutral, and ground in to each one of them. The other thing is that you've got 2 legs of 120, right? L1, L2 off of your breaker box. It's important that whatever you use on the one box, you use that same leg on the other box. Otherwise, you'll create a differential of 240 volts.
And then with several twist-top actuators, say within a manifold box, I think he's talking about a box mounted on the wall, you could install one of the zone controllers relays inside the manifold box, right? Sure, it'd just communicate back with the other ones. Yeah,
right. You could remotely mount it again as long as the 120 volt is on the same circuit.
Yeah, and I think Mark Etherton just asked a question about the exercise on the zone relay. Obviously, you can't exercise that pump if the valves are closed. That's the key there, right?
Well, actually, it does, Bob. We spoke to the pump manufacturers on that, and they said that the 30 seconds of on time would be fine with their pumps every 72 hours even.
Regardless of what type of pump, even a high head pump or something?
Well, that's what they're telling me because it's such a short span of time. And I know even like with the Alpha and stuff like that, the Alpha probably takes like 15 seconds before it actually gets done with its initiation and junk. But yeah, I'm told it would be fine with that.
Okay, another question. No, we only got 10 minutes here, but I think we're pretty close to the end. I take it from the opto relay that the zone valve motors outputs are Triax. Use Triax. I mean, I think that's an optical relay. Doesn't have to be a Triax.
No, the optical is only on the feedback. Is only on the end switch.
Oh, okay.
Okay. But the other ones, on these other ones, you're basically passing through. You're passing through your thermostat down on here, and then there's a relay in here to hold off the other zones. But the optical is on the feedback coming back.
Right. And then I know you touched on this on one of the slides that you previously had. We had all those zone valves without a pressure bypass on it. Again, we don't have expansion tanks or fill valves or some of the hydronic hardware in here that, of course, you'd want to have. We're trying to keep the drone as clean as possible. But, yeah, you're right. Anytime you have more than 4 zone valves, it's a good idea to have either a variable delta P pump or have a pressure-activated bypass at the end. That was a good catch. Thanks.
Right. These are just to show, the basics of where the pumps are and where the valves are. Right? Like in this one, I have no air separator. I have no fill kit. I got no expansion tank. I don't have a pressure differential bypass valve.
Right.
We'll get those in. We are working on a wiring guide, which is really going to be nice because we're going to do all of these different types of schematics, and then we're going to have the sequence of operation right next to it. So that you can basically look at the index, see what kind of system you have, go to that page, see the physical, the plumbing schematic, and then also see the electrical schematic and the sequence of operation.
Yeah, so it'll have all three. It'll show you this with all the right components, of course, and there's a piping schematic, and then the wiring schematic, and then the sequence. So I think it really clears it up, and of course, in a nice booklet color.
So here's another, this is another basic one. Kind of touched on this before, but if you had 6 zone valves, a system pump and a secondary pump, the control could control all of those items in that system, in that particular system. And getting a little bit fancier here, we have 5 heating zones, our secondary pump, a system pump, and a priority pump. And of course, many boilers can't control that, and that's fine. You can do that if you choose to. Or you could wire them to our control. Space heating is, just as we said, if you get a call from for heat, it will turn on that LED. It'll send 24 volts to the corresponding motor. Once the end switch is closed, the other LED lights up. The system pump and the secondary pump would turn on, and the XX contacts would close, delivering heat out to that zone. If the aquastat calls, it will drop power to any of these zones. And in this case, we're using a priority pump, so we do have to put a jumper in the end switch. But the call for heat LED will illuminate, number 1. And the end switch light will immediately light up because the jumper's in there. So it'll shut down your secondary pump. And in this case, it would also shut down your system pump because we would want this off. And it will fire your priority pump. It will also close the domestic hot water contacts, so the boiler goes to high fire. So we'll load up that indirect. And once it's done, it'll pop back over to normal heating mode. This one we took a little more care on. At least we got a fill kit and expansion tank in there.
Yeah, a little more hydronic stuff. Okay. I think you had one more, even more complicated, where didn't you daisy chain 2 of those? There it is.
Yeah, this one I put in here because I wanted to show a couple of things. This is a daisy chain. We got D over to D. Actually, yeah, we do D to D and P to P and ground to ground. But what the point on this one I wanted to show is that we have 2 secondary pumps going out to manifold pumping stations, like a Caleffi 171 or 172. But what we're doing here, let's say you got a call for heat on the second board. We'll call this the B board over here. And let's say zone number 1 on the B board called, thermostat calls, LED illuminates, and it sends 24 volts out to the thermoelectric actuator. Once the end switch closes, this other LED, the end switch, the valve open and light will illuminate, and the control will then send a signal back to the master board to say, I have a call for heat over here. And the master board will then it will close the XX contacts to tell the boiler there's a demand, and it will also fire up the system pump, but only the system pump. It will not run the secondary pump on this board. This board will fire up its secondary pump. The secondary pump is related to the board that's getting the call for heat. So in this case, if this zone's calling, this pump is running, this pump is not running, and the system pump is running. So we're delivering, we're delivering fluid out to this zone out here and back.
So the key to that is the B pump has to go to the B, what you're calling the B pump on the second manifold has to go to the B board.
The B pump would have to go back to the B board.
You couldn't
correct.
just wire both A and B pump to one relay on the first board, just like jumper across or something. You have to go back to the board that it's.
Yeah, if you did that, both pumps would fire at the same time.
Yep.
Right. But this way, you could think of this too. This could be zone valves, regular zone valves, and you can put multiple secondaries. Basically you got 6 zones per secondary pump that you could do then. But it will communicate back over there. Now, one thing to keep in mind too, and I don't think I have a slide on this. If you did have 2 boards, let's say you had 12 zones and you only had 1 secondary pump, at that point you would need to run your secondary pump. Your single secondary pump over here would need to come off of probably the system pump contacts would be the best place, because that way, because the system pump always runs when there's any heat demand at all from either board. So you would need to use that set of contacts for both your secondary pump and your primary pump, in that case. It's kind of a special case, but we'll have that. We'll clearly show that in the wiring guide.
Yeah, and we started putting this manual together, and there could be hundreds of different variations of how the guys are wiring this. And we're going to get as many as we can without making a book that's 15 pounds. It weighs more than our transformers. But another question here is this a good one? I thought I put this one. If you have zone valves without end switches.
Sure. You can do that. You just need to put a jumper on the end switch contacts. And then as soon as the call for heat comes, it'll deliver 24 volts here, and it's gonna go and fire the pumps though as soon as that happens, because we usually wait till the end switch is closed, but if there is no end switch, you can just jumper it closed.
Yeah, and then on a thermoelectric, of course, it'll take that time to open, but it shouldn't be a problem. And then can you? What was the other question here? That was a good one. Can you wire 3 actuators to one thermostat? So, and that's a question that comes up a lot. So let's say this manifold up here, all of these are on 2 different thermostats. So you got a living room that has 3 zones going out to it. So A1 through 3 is on one thermostat, and these are on the other thermostat.
It is possible to do, but the one with our, let's say this was only a 3-zone box,
right?
And you purchased the extra transformer to have more juice.
Yep.
But keep in mind that the juice that it takes to open those actuators is still going to flow through the thermostat. So the thermostat still needs to have some capability to be able to control all of those.
So the key is really the thermostat. Can it handle that current draw when all 3 of those hit at once? It's not that we can't do it. It has to, like say, flow through the thermostat. And probably not, I would say, on a thermoelectric type of actuator that 3 of them could go.
Well,
I don't know. You have to read the spec on the thermostat.
Yeah. One thing to point out there too is that we did come out with a low current draw thermoelectric actuator last year. So it only pulls 250 milliamps at pull-in, and then drops down to about 100 milliamps. So, if it is an issue with the current draw on that, I'd ask you to look at our 6564 series, which has real low current draw for a thermoelectric actuator.
Yeah. And that was the key to that, because guys said we wanted to put multiple actuators on one. How can we do that? Well, one of 2 ways. You have to have a thermostat that can handle the load, or we built the actuator with a a third the current draw of the regular thermal actuators? Yeah,
it's quite a bit less, yep. It takes a little longer to open, so I think it takes around 2 minutes or so to open, but it's very low current, so you don't have those issues associated with the normal thermoelectric actuators. So let's keep rolling here. I noticed we're at an hour already. This was just the last one to show us that it's doable. Basically we got some circulators for zone circulators, primary pump, priority pump, and then like I mentioned before, maybe you would want to, you're adding on another, area to the home, and you just want to do another pump with zone valves. Well, we've got our pump board here communicating back to a valve board over here, and if one of the valves would call for heat, this thermostat calls for heat, powers up the zone valve. When the end switch closes, this secondary pump would fire. This board would communicate back to the master board that there's a demand. XX contacts close, so the boiler fires, and our primary pump in this case would fire. So it knows there's a heat demand, and you'd be able to supply those zones out there with heat.
And then the key is that secondary pump over on the very far right has to go to the second, right? Yep. To that board.
That's correct. Yep, has to get wired to that secondary board. And if there's a priority call, this board will communicate over to this board, and it will hold off all of these zone valves, and the secondary pump will not run when there's a priority call over here. So this is a true possibility. So, and this is we just wanted to, we talked a little bit about the PressCon. We're bringing it out on a few different products to start with. It's 3/4 inch copper press on zone valves, a couple of different zone valves, our magnetic separator, we've got a thermoelectric actuator valve down below here, as well as a 3/4 inch pressed, 3/4 inch fill valve, and a 3/4 inch pressure differential bypass valve. So those of you guys that are looking for press, got that now.
Or just the tail piece, if you've got a valve that has that 1 inch, what do we call that 1 inch G thread that fits on?
Right. Yeah, these are in the catalog. These are in the catalog in packs of 2 and 3 separately. And in the zone valve, too, we have it in a 2-way and a 3-way.
Yeah, that's why the 3-pack, so if you're using the zone valve for diverting or something, we've got the 3-pack for that. And it's a really nice leak pattern. You can see kind of the end view of our leak path and our O-ring there. We've got like 9 or so leak paths, so if you happen to have your leak path against the wall, you might not see it dribbling down the back. This one, and we've tried it. I mean, it sprays out like a lawn sprinkler had one that leak, so we think we've got a pretty good mousetrap there. So I think, Mike, just what's coming up next on webinars. Yeah, we'll talk about all the different zone valves. Again, we'll cover the different ones that have the press applications on the next one in March, Coffee with Caleffi. CV, this is something we get a lot of questions about. I don't know that a lot of people understand what that is, how it works, how you apply it, how you do that. So that'll be coming up in April. And then a crowd pleaser always, John Siegenthaler is going to talk about air source and water source heat pumps again for hydronic applications. So I think, any more slides? I think that's it. Again, if you want the certificate of attendance, just when you close out of this, when you're done with this, or we close it out, do you want to participate in the survey? Again, yes, to answer that one question. You don't have to answer the 3 or 4, but we'd appreciate it if you did. We just want some feedback on how we're doing and what else we can do to serve you folks as far as upcoming products or webinars or whatever you want to, whatever's on your mind, let us know. But thanks, everybody. That's the group that's heading over to Italy here in a couple of weeks, and hopefully you're in the next group. Certificate, that's what it looks like. It'll be mailed to you. Anything else? I think that's it. Again, thanks, everybody. I know we ran a little bit late. Questions, send them in. We'll get to everybody as far as this product or any product you might have questions about, and we'll see you again soon. Thanks, Mike.
All right. Thanks, everyone.